All right, the numbers seem to be stabilizing now, so I'm going to go ahead and get started. Welcome to this, the 9th, I think, CNCF webinar. My name is Mark Coleman. I'm the CNCF Marketing Committee Chairperson. Today, we're very pleased to have Josh, Mark, and Camille from GitLab with us to talk about getting cloud-native applications from development and to production, I should say. Before we get into it, a couple of live guidelines. Please don't leave all your questions to the end, because this works a lot better when it's interactive. And you'll probably already know this, but you cannot speak during the webinar. So if you do have questions, put them in either the Q&A window or the chat window, and I will find opportune moments to ask the presenters those questions. Josh, Mark, and Camille, are you ready to rock?
We are. Thanks, Mark.
Excellent. Take it away.
All right, so today you have myself, Joshua Lambert, product manager here at GitLab, along with Mark Punsock, who is our head of product, and Camille Trzynski, who is our CI lead at GitLab. So I was doing most of the presentation duties, but we'll have Mark and Camille available for all of your questions. So as Mark mentioned earlier, please toss them in chat or in Q&A, and we'll get to them throughout the session today. We'll be a little high level in the slide content, just because we can possibly have a pretty broad range of the audience. But if you have detailed questions or technical questions, please again ask them, and we'll certainly address them as we go along here to help keep it interactive and make sure we're giving you content that you're looking for here. So as far as what we're going to cover, we'll first kick off with, again, just a high level kind of baseline setting, introduction to cloud native, what it is. We'll then go into why it's important and why it's important for your businesses, your organizations. We'll talk about some challenges you might bump into on the way to embracing or moving towards a cloud-native architecture. We'll then get into some getting started recommendations, and then also a demonstration of how you can potentially automate your applications from development to production as well. So let's jump into it here. And we'll start off, of course, with what is cloud-native computing? And we'll use the definition here by the CNCF, who would know best. And they state it to be that cloud-native computing uses an open source software stack to be three things. 1, containerized, 2, dynamically orchestrated, and 3, microservices oriented. So let's go into a little more detail on what each of these means. Again, pretty high level here for folks. If you have more detailed questions, ask them, but trying to help set a baseline here for others. So, what is a container? Well, the Docker team defines it as a lightweight, standalone executable package that includes everything needed to run that piece of software. And that sounds great, but what does it kind of mean, especially in particular to sort of the previous computing models of the past? Well, way back in the early days, you had bare metal, where you essentially had your machine, an operating system running on it, and you install applications kind of commingled all in the same machine. This was great, it was efficient, but there were problems around dependency management. Applications could impact each other, and trying to reliably deploy software, especially at scale, was a big challenge. So end-to-end virtualization, we could essentially have a computer kind of purpose dedicated for a particular application, and you could run multiple of these on a single piece of hardware. This allows you to have portability, isolation between virtual machines, and also be able to more reliably run your software and deploy your software. With containers, you kind of get a lot of the benefits of the virtual machine, but you can see that we're actually dropping that OS layer, right? We're not trying to virtualize an entire operating system for each of the individual VMs. And so the benefit here is you get sort of the isolation and security benefits, but without some extra overhead, right? So that's kind of the main difference there between containers and some of the earlier models. And so the key benefits really are they still maintain the isolation and the security features predominantly of the VM model, but they're far more efficient, right? So they use less CPU, they use less RAM, and they can start and stop much, much more quickly, right? In this case, in seconds, as opposed to having to boot up an entire operating system and then have an application start after that happens. They also maintain the ability to be really repeatable, right? So they're version controlled, they're hashed, and you can reliably deploy the application the same way every single time. And this is really important, of course, when you're talking about deploying and running software at scale, as well as having an automated process to make this work reliably and efficiently for you, and to do it time and time again very, very quickly. So that's a brief introduction to containers. So let's move on to point number 2 here, which is getting into kind of what comes next, right? So if you can imagine our containers kind of give us a model to say, have a piece of hardware or a boat. You can stack on a whole bunch of containers on top of that, and you can set it off into the world, let it do its job, and it'll go ahead and get those containers where they need to be and continue to function properly, right? But what happens when you have, say, a whole bunch of containers, right? Hundreds or thousands, and you have a whole bunch of ships, right? How do you coordinate, what containers go on what ships, where the ships should go, what they should be doing? And for this, you need some higher level constructs than just the actual container system itself. And so this is where orchestrators come in and can help solve this problem, right? So their key advantage is that as a developer or an organization, you can simply provide them a description of an application or a service, right? You can say, I have an application that requires these containers. They need to talk to each other in this manner, as well as with the outside world in this particular way. And they have these storage requirements. And the orchestrator takes that definition and then effectively makes it happen on your hardware, right? So it will efficiently deploy that application onto the system, provision and stitch together your containers, make sure the compute is aligned and provisioned correctly on the hardware you have, as well as attaching the storage as you defined as well. And so effectively, you can deploy your application without you worrying about what hardware it's running on or the underlying details. And it can do this very, very quickly, right? So it can go ahead, deploy your application, use containers that come up quickly. It can then scale them. It can update them and then also stop them as needed. And it can even perform maintenance tasks here as well. So for example, if your orchestrator like Kubernetes notices that one of your particular nodes or pods is unhealthy, it can actually stop it automatically, spin up a new copy and restart it and kind of have some self-healing properties without your users experiencing potentially any issues. So it kind of provides that additional layer of that infrastructure automation, and it in particular lends itself extremely well to automation and programmatic interaction, which makes this really great to work with, again, at scale and within your pipelines. So that's a bit on orchestrators. And the third point then is microservices. And this is potentially a very large topic, but pretty important, right? And this is essentially an architecture or development model where you take your application and you actually build it as a collection of smaller independent services. And this provides a few key benefits. Number one is you have improved horizontal scalability. So rather than a single monolith, you have these individual parts that have been built to interact on the network layer, right? So they aren't trying to leverage local file systems or some local ports or sockets and things like that. And so they're much more able to be scaled independently because they're already having an abstraction layer between them. You also aren't trying to stamp out, say, a monolith n number of times where you only needed to actually scale a particular portion or part of that monolith. And so it gets more efficient there as well. You have the same isolation between services. So this allows you to actually have reduced testing surface area as well. So if you're revving a microservice, for example, you can be confident you're not touching anything broader than the actual, the whole product. You're not deploying the whole thing anyways. So you're only deploying and revving an individual component. And you guys, of course, just make sure that that one continues to work with the surrounding services. And this all boils up to allowing you to having the ability to more quickly iterate on each individual component by being able to deploy it selectively, scale it individually, and also have a reduced testing surface area there as well. So that's a real quick introduction to some of the key tenets there of cloud native computing. And with that, let's get into why it's so important, right? So why should you go down the path of microservices? Why should you kind of embrace Kubernetes perhaps and go and build Docker containers for applications, outside the benefits that we kind of noted earlier? Well, in this case, Forrester went through and did a comprehensive development survey in 2017, so this year, right? And the top 4 priorities that came up from their survey were the following items. Developers wanted to increase automation of their SDLC process. They wanted to use more cloud-based development environments. They wanted to, of course, improve the customer experience and the metrics therein, and also, of course, to improve and speed up their cycle time or the rate that they can actually iterate on their software. So these are all pretty important tasks, but they're all fairly interrelated as well. And they also have a lot to do with cloud native and its goals as well here. So let's talk about these in more detail here. The first and kind of most important to your business, of course, is improving the customer experience, right? Because every company these days is either a software company or going to become a software company. That's because more and more of the customer experience is in fact digital, handled by software. For example, how many folks will go to the bank and actually say cash a check voluntarily by walking in? almost no one does that anymore. They take a picture on your phone, deposit electronically, it's a much better experience, right? So that's just one example, but if you aren't trying to take this seriously, if you were having a digital presence that you're actually competing on, someone else will come in and do it, or a startup will, and your business will be in trouble, right? So this is really important to try and make sure you're delivering a great customer experience. So, how do you do that? Or how do you deliver a great customer experience? Well, the way you do it is to try and increase your cycle time, right? So previously you might have this great idea on how to increase your customer experience by building this great new feature. It might take you 6, 8, 9 months to go ahead, plan, build, and ship. And you might learn that you actually kind of missed the mark by a little bit, even though you did a good job, right? You're off by some percentage, right? And you're kind of missing opportunity here because you've spent that whole lot of time and you kind of already missed the mark to some degree, right? And by increasing the cycle time and iterating more quickly, you can deliver smaller features and actually learn from them, right? So instead of perhaps having these big type of zigzag approaches, you can more finely tune the software delivering based on feedback earlier. You can also adapt to any kind of changing market conditions as well, much, much more quickly, right? And so you can arrive at the optimal solution much more quickly, much more efficiently with less waste if you had sort of these longer cycle times where it would take you perhaps months or weeks, for example, to just get initial certain revisions out to your customers. So that's obviously a really important way to make sure you're building the right things for your customers at the right time. So then how do you actually speed up the cycle time, right? How do you achieve this? Well, of course, a key component is to automate the entire SDLC process, or as much as you possibly can. If you have humans involved in the release or the deployment process, it can take a long time. You're wasting effort by having people doing this. And it's also error prone, right? So if you actually want to be able to achieve the ability to deploy every day, every hour, maybe even every week, you really want to make sure you have your pipeline automated so it's reliable and it's hands-free. And you can, of course, again, continue to increase that cycle time and ship additional content more quickly in the smaller pieces. And so, how do you automate this? In particular, how do you automate the more kind of back end or tail side of your pipeline, right? More the continuous delivery angle of things. Well, cloud native really makes that much, much more easy to accomplish, right? Because we have orchestrators which are built to be programmatically interacted with. You can hand them a definition and it'll go ahead and simply deploy the software and essentially make it so. And this is much easier than trying to have to manually trying to worry about these things like firewall rules, networking, and things like that. And the goal here, of course, is to try and move towards more of a kind of a cattle model instead of a pet model, right? So previously, if you had, say, for example, a single node or a single monolith handling order taking or credit card processing, right? That thing was very much a pet. If it got sick, if it couldn't process orders, that's a big deal, right? It's kind of like the family pet. If it gets sick, people are crying. It's a problem. And the better model is to make sure that you can actually have resiliency built in and you can deploy fixes and perhaps even necessary roll back much more quickly, kind of like a herd model, right? So poor cattle, right? If you take a herd of cattle, if one gets sick, it doesn't really matter all that much. You have many, many more that can take its place, and maybe that one goes off on its way to McDonald's or something like that, right? But the show goes on and it's not that much of an issue. So this is the model you want to go to and make sure you have resiliency, and a lot of the cloud native architecture and components can help you achieve that with the microservices, the resiliency therein, and also the ability for orchestrators to kind of deploy software automatically as you define it with your organization. So some key benefits there, and really why you want to focus on cloud native to begin with here. So that's some of the benefits there of cloud native. And so let's talk a little bit about some challenges you might encounter along the way here. So one of them, of course, is DevOps, right? So as you have your developers who are now responsible with perhaps building Docker containers and responsible for kind of controlling how much resources they require, what network ports they require within the orchestrator, they're going to be involved inherently more in the operational side of things. And so you need to have a healthy and mature DevOps organization to have that collaboration and the lines of communication open between perhaps your production team or how that looks in your organization and your DevOps team, and ideally have them functioning as one cohesive whole, because it's going to blend together more and more as time goes on. So depending on where your company is in that maturity cycle, this could potentially be a relatively large hurdle, depending on how sort of set in your ways or perhaps your company is from a culture standpoint. Similar to the kind of culture is the technology, right? So if you are still sort of in the virtual machine era and running things that way, it might be more of a transition to move on to containers and to orchestrators and to some of the cloud providers and other services you can use to kind of embrace the cloud native model. So there's probably some expertise gaps there, you have to do some learning, as well as perhaps also some architectural challenges you might bump into along the way of embracing microservices. And we can talk about some of GitLab's experiences there a little later in the deck here as well. And then finally, once you have your software deployed, you might also bump into some operational concerns, right? So troubleshooting and working with microservice applications is a little different perhaps than you used to maybe with a monolithic application. Trying to figure out what happened to a customer request that generated an error might involve a handful of different microservice calls, and tracing that and figuring out where the issue was, again, perhaps could require some new tooling from your organization. And so you want to make sure you're set up for that and are able to handle it as that occurs. So those are some high-level challenges of going cloud native, and kind of transitioning into some recommendations on how to most effectively get started, right? So I think it's pretty clear we all want to try and get to the cloud native architecture if you aren't there already. And so, kind of what we've seen in the past as far as companies who have done this and what they experienced was a few kind of key points to keep in mind. Number one is make sure that you aren't already, that you have a healthy DevOps organization and DevOps culture that you can use and rely upon as your developers and your production teams become ever more intertwined as kind of the lines blur between the teams. Second, try and identify a good candidate application or service to try and learn on, right? So find one that's low risk, relatively small, and you can go ahead and kind of try things out and learn how to run these things at scale with customers kind of in the real world, right? And so don't pick the most sensitive, high risk project, right? So choose one you can learn on and get the processes and get the best practices that you can then use to go forward and kind of move on to ever more sensitive and more important operations. Next, of course, make sure you have a conducive development tool chain. So perhaps some of the tools that you're using in the past might not be so relevant in this model, right? You may have some new challenges, for example, on troubleshooting or monitoring and things like that. And so, kind of keep an eye on things in that regard as far as, is your development chain still supporting you as you move towards a cloud native architecture? And can you actually still kind of, again, achieve your operational goals and have the information you need to operate your business? Finally, of course, is then just start actually, automating your pipeline, right? So you want to make sure you can go ahead and build your Docker files automatically, and then take those, deploy them to perhaps some dynamic environments to have allow your developers to kind of see the code live, interact with it, and make sure it looks good. Doesn't just look good on paper on the merge request page, but also actually interacts and looks correct if you're actually looking at it from the perspective of the user. And then also just continue to automate your deployment process all the way through to ideally production as well. Although perhaps, again, there might be some gates there for manual intervention as you kind of progress down that path. And then once you have your pipeline automated, of course, then you want to ship, iterate, and learn, right? So get it out there, figure out what happens, figure out what kind of issues you run into and how you can troubleshoot them, what tools have to go on the way, document all that process and really kind of share that knowledge then with the next team, right? So we've seen it effectively where you kind of take that one small application, you establish some best practices, what works for your organization, your culture, and then you can then use those and also perhaps seed some of the next team with those same people so they can kind of help out and reduce the time to get started with so you get familiar with these different tools and different hurdles they may have in going this direction to cloud native architecture. So this can really help to accelerate that. And then once you found you kind of done this a couple of times in your organization, a couple of projects, it starts to snowball. All the development teams sort of hear about the velocity and the tools and the technology that other teams are working with, and then inherently kind of become a little hungrier and want to embrace them as well. And so it starts to kind of snowball and sell itself internally as the benefits become pretty real, I think, across the organization. So this is kind of the model we've seen work pretty well in the past as far as getting started down this path to getting your applications from development to production. So with that, we thought we'd talk a little bit about our own journey here at GitLab. So we kind of started off with obviously kind of a more classic architecture, and we're moving towards a cloud native architecture. We can talk about some of the things that we've experienced along the way here. So for those who aren't aware, we here at GitLab offer both a SaaS service, GitLab.com, as well as also a self-hosted installation. And it actually comes from the same code base, right? So the same code we use to run a web scale multi-tenant SaaS platform is also the ones we give to our customers to self-host and run. And so they can kind of offer those same multi-tenant capabilities to their own internal customers. And we deliver this primarily as what we call our omnibus package as our foundation, right? And what this is really a package that has a whole bunch of stuff in it, right? So we have multiple parts of GitLab. Those are all baked in there. But we also have all of our dependencies and all of the other attendant kind of intelligence and deployment tools also baked in as well. So for example, that one package contains Postgres, Redis, Nginx, Mattermost, the container registry, Prometheus, and even more, right? So it includes everything you need to have a completely full-blown GitLab deployment all in one place, right? So you have multiple processes, multiple services, multiple ports, all this kind of software all living in the same place. Now, that's pretty complicated, but it has been absolutely fantastic for traditional self-hosted installations, right? If you boot up a VM or a set of VMs, you can install this with a simple apt-get install command, and you get all that complexity that's all been distilled with the kind of our chef scripts to become very, very easy. You simply run install, you run reconfigure, and you now have an operational GitLab instance, and we've kind of hidden all of that complexity behind our kind of packaging scripts. And so it's been very, very helpful, not just installations, but also for updates. But you can imagine kind of trying to move this towards more of a cloud native architecture, there has been some challenges, right? So the first iteration of our Docker image is based on our omnibus package, right? So it's basically a Docker version of our package, and therefore it has all those same components all in the same thing, right? So it's kind of an all-in-one or a fat container. We also have the Helm charts as well that are available, but they still depend upon that same Docker image, right? And so we started to bump into not just the classic monolith problems, but also some additional problems with all those extra services that we were bundling in. And so we had some challenges around scaling and complex deployments, again, kind of similar to monolith, right? So for example, when trying to run our GitLab.com service, we had to scale out our, some different nodes up to 10, 20 types of nodes. And we had the same package that ran everything, right? So we had these scripts that deployed it, but then turned off certain parts of the package, so we weren't scaling out the entire thing to these different services, and only scaling out the parts that we actually needed to, right? And so there's complexity there. We also had this whole kind of, again, this package with all this intelligence baked into it, but that meant that it took a long time to come up, right? Because we had to tell it what to use, what not to use, and then in the startup, it would of course go in and configure all that, right? Shut some things down, turn some things on, and that all took time to complete. And so the net result was that there wasn't really an easy zero downtime solution in the cloud native kind of model, and nor was there an easy redundancy solution. You could kind of work around this today, and customers certainly did it, but it wasn't, again, kind of meeting that cloud native architecture, and it wasn't as easy or as automated as we prefer in our Helm chart. So that's kind of where we're at, right? But we're aggressively moving towards a more cloud native architecture here. We have an active project underway to help accomplish this, and we're moving as quickly as we possibly can here. So our goal is to, again, move towards a more cloud native friendly architecture. We're gonna go ahead and actually kind of offer a smaller set of cloud native containers and charts, right? So we'll use a single container for each of our services, right? So what that means for GitLab, we'll have our GitLab workhorse, our Rails instance, Sidekick, and other components all separated. We'll then also have separate charts and containers for the other components like Sidekick and Unicorn and Mattermost and things like that, right? So we'll have a whole kind of collection of these, all individually available. But of course, you don't want to have customers exposed to all of that complexity. And so we'll still have a sort of a top level GitLab Helm chart, which will be available to deploy, stitch all of these together, and then have a single place you can pass configuration into, which would then, of course, pass that down to the subcharts, and then they would then, of course, spin these things up as needed and configure them accordingly. So that's how we're tackling sort of the packaging and the bundling of our service and trying to split it up and make it more consumable and scalable and cloud native. But of course, that wasn't the only challenge we ran into, right? So we also had some architectural challenges as well. So one example is that our Git layer currently requires like a shared storage layer to actually operate in a highly available or a scalable way across multiple nodes. And that wasn't great because that, of course, became much like a pet, right? If that NSS server had problems, it was a big, big deal. And so we're actually going through and rewriting our Git layer to eliminate the need for that shared storage service, right? And we're calling that Gitly as part of our internal project. And that'll help to remove some dependencies and be able to provide more resiliency and redundancy over time as we make progress there. We've also, of course, found some areas of our product that, while we thought were relatively split up, actually still had some dependencies, right? So we found, for example, between our Git layer and between our Rails layer, there were some assumptions made that they were communicating with local files. And obviously, once you start to move towards more of a microservice model, that doesn't work anymore because you have to have that network layer in between. And so we're going through, finding these, looking at them, and working to solve them to help, again, kind of achieve that isolation and the cloud-native microservice architecture that we're looking to achieve there. So that's some of the challenges that we've run into here at GitLab. I'm sure we'll bump into a couple more as we make some more progress here, but that's kind of what our journey has been and where we're going. But again, we think it's totally worth it, and we're aggressively pursuing this and trying to get this out as quickly as we possibly can. So that's a bit on our experience here. With that, we can move into a demonstration and talk a little about perhaps how you can build a pipeline that can take your applications from development all the way to deploying on Kubernetes. Just give me a second to get my browser shared out here.
While you're doing that, Pax, I can jump in with a question. It appears that the benefits of going cloud native are pretty obvious, but you mentioned some of the challenges. And one of the things I'm interested in is, as you introduce all these extra moving parts, how does that affect your testing strategy for new software that you're pushing out?
Yeah, sure. What we're doing, of course, is that we've invested heavily in the number of CI tests that we have. We're also investing heavily in what we call GitLab QA, which is our integration test service. And so as we go down this path of kind of splitting these out, we'll be making sure that we, of course, have test coverage across the board on kind of the unit test level, but also we have the ability to go ahead and deploy the full Helm chart and ensure that we can actually stand up an environment and then have those integration tests running against that complete sort of deployment on Kubernetes, right? So we're actually going through that right now and having a pipeline built that will go ahead and build all the Docker images. We'll then go ahead and build the Helm charts, and then actually then take those and deploy them out into an environment that we can then dynamically stand up as part of the CI test and the integration test, and then run those tests against that new environment. And that way we can help to make sure that as we make changes to these individual components, that they're still going to function correctly with the broader whole. We also have the ability to have cross-project pipelines. And so as we have for example, GitLab Workhorse or Gitly, which are individual products or individual projects within our kind of SCM system or GitLab, we can still go ahead and after the test pass with that individual, say, microservice, we can then go ahead and actually kick off a downstream CI test as well to ensure those continue to pass. And kind of that integration step I mentioned earlier is going to be one of those stages as well. So that's kind of how we're looking to structure this and kind of build a pipeline to make sure that we can, of course, build our assets, but also make sure they still test and pass when we're getting ready to release them.
And if I understand correctly, sorry, go for it.
No, I was just going to add to that, that on the one hand, it's a little bit more complicated because we have multiple targets now. So, we still have a lot of customers using our VMs, and we definitely need to continue supporting that. And so we have a more complicated test strategy because we have two targets. But on the other hand, going cloud native actually is a lot easier to be able to test these things end to end because we can spin up entire virgin clusters to do installs, and we can automate all of that. Whereas, you can do that with VMs, but it's a lot harder. It's so much easier just doing it with spinning up a Kubernetes cluster, and we can do all that by APIs and even do that in our own CI. So it's kind of a double-edged sword there. But if you're just doing cloud native going forward, I would imagine it would actually be a lot easier because you wouldn't have to deal with the multiple targets problem.
Thank you.
All right, thanks, Mark. Definitely keep bringing up those questions as we get them in here. So this is our GitLab interface. I just have a pretty kind of an instance I actually deployed on Kubernetes here just earlier today. So this is kind of brand new here. I'll go ahead and make a new project. And we'll use a Git repo to make things a little more quick. So we'll have a minimal Ruby application you can use as our sort of test bed here. We'll make it public because why not? And we'll just do a quick little repo import here. It's a couple handful of files, as you can see down below. We've got a Docker file, some gem files, right? So you kind of your typical Ruby stuff. And then we have our rake file and our tests, and then also our basic Ruby source code here. But let's take a look at what else we have going on as far as our settings. So I can jump into our CI/CD pipeline settings, and I can go ahead and enable a feature we call Auto DevOps. What this does is it actually sort of has a pipeline definition built into it, which can identify and detect your code and go ahead and build it, translate it into a Docker file if you don't have one automatically already or included in the repo. You can then take that Docker container and then deploy it into Kubernetes using a Helm chart that we have by default. If we have a Helm chart, we'll actually already use that as well. And so it can go ahead and kind of take advantage of what you have. And if you don't have something like a Docker file or Helm chart, it'll go ahead and try and generate one for you based on what it kind of knows about your repository. And so this can make it really easy to go ahead and kind of start deploying into Kubernetes with your software here. So we'll go ahead and save this. And I think I missed my click there. There we go. So that's now turned on, right? So we have kind of that automatic pipeline. We can then take a look at what runners we have available for us. In this case, we have a runner already set up. If you take advantage of our Kubernetes installation method or a Helm chart, you get a runner automatically configured for you. If you don't have a runner, you can, of course, go ahead and configure your own. And this is kind of what powers our CI, if you will. We also have some integrations that come out of the box here as well when you're deploying onto Kubernetes. Of course, you have your Kubernetes cluster information. Again, this comes automatically configured for you if you install on Kubernetes. If not, you can simply enter this manually for your own cluster. And then we also have Prometheus, which is an open source monitoring solution, which is also great for cloud-native applications. And we can use this to go ahead and get metrics on the applications that we actually do deploy into Kubernetes. And so that's what we've got going on here. So we'll go ahead and take a look at our server.rb file. We'll make a quick change. We'll say, hello, brave new world here. We'll just commit right back into master. And you can see we now have a pipeline now running, right? So in this case, we're going to go ahead and take that Docker file, which is in a repository, build it, right? So we get a Docker container. We can then use that to go ahead and run tests against. And then we'll go ahead and also then deploy it into production, in this case, directly, because we committed, in this case, directly into master. So that's pretty cool. We have a pipeline already running for us, deploying our first version out into the world. Well, let's go ahead and do a kind of more typical update here. You can see we have a to-do that was sort of waiting for us. So we can go ahead and remove that and add this. So we'll add HTML, right? So we'll say HTML, hello, bold, cloud native world. If I can type, we'll be all set. There we go. That looks good. So we'll go ahead and commit that. We'll make a new branch because we want to review and make sure we got the HTML correct, for example. And this is, of course, a best practice here, not to just be committing directly into master. So we'll go ahead and create a merge request so we can review our changes. And here we go. And we, of course, now have a new merge request running here, our new pipeline running. You can see we've got our build stage, which is already running as well. We also have our test stage, which will go ahead and run a static analysis report of our code repository. So we can see if there's any kind of vulnerabilities or things we want to be aware of. We're going to run our tests. In this case, run rake test because it's Ruby. So we can automatically get that running. And then we'll also create a Ruby application. So let's take a look at what this looks like here in these build logs. So you can see in this case, we went ahead and are building our Docker file-based application. Again, if you didn't have a Docker file, we would simply detect your code and go ahead and actually build a Docker file for you based on what we find. So that's already complete, and we've uploaded it to our registry, so that's great. And we can see we also have our tests running here, they just passed. And so you can see in this case, we detected that your Ruby application, and so we went ahead and executed just simply bin rig test, and that also passed. So that's great to see. So going back, we're going to have our second analysis run, which completed, and then we have our review application. So review apps are pretty cool in this sense because we have the orchestrator and we have our containers. It becomes, as Mark mentioned earlier, really easy to go ahead and simply stand up temporary dynamic environments, right? The benefit here is that you, of course, can go in and you can see the code changes, which look pretty simple, but the real kind of test, of course, is to actually look at this running live on an environment. And you can see we have a link right here I can click on, and I can take a look at that change I just made running on a real environment, real containers, running on Kubernetes, and make sure that it looks good. So that's pretty cool and looks great. The other neat thing that you can see here is that with the static analysis run, you can see we've actually improved our code quality, right? So what happened here is that we actually ran that static analysis job. We collected the results. We actually compared the results that we got back to our master branch, which is where we're merging into. And you can see in this case that we're simply telling you, you know what? You actually cleaned up and addressed that to-do, right? And so you fixed that problem. And so that's pretty cool. It doesn't give you the whole report of all the findings, just the delta between these two branches, which as a reviewer is what you particularly care about. So this looks great, right? The code changes look good, static analysis looks good, and our review application looked exactly the way we wanted it. So we can go ahead and hit merge. This will continue on to tearing down a review environment to save some resources, and then kicking off another pipeline here to deploy back into production for our new version of code. So let's take a look at production here. So here's our production environment. We can click down and we'll see that we have a representation of our deployment, right? So this is actually a pod by pod view. Pods in Kubernetes speak is sort of like a node or the instance of the container that is running. And you can see we have one instance here which is running and it's healthy, right? So that's great. And again, in this case, if it wasn't healthy, Kubernetes could kick in and actually go ahead and try to restart it if necessary to fix some problems. We also can simply pop open our monitoring dashboard and take a look at that. But first, let's take a look at our environment. You can see in this case, we're still running our previous old version, right? So our hello, brave new world in this case, because our pipeline hasn't quite finished just yet. We can also go in and actually pop open our monitoring dashboard. And again, since we just kind of deploy this, there won't be too much here, but you can see metrics in this case are already coming through. You can pull back error rate, latency, and the throughput. And again, this is all coming from the metrics that get built into Nginx Ingress on the Kubernetes side, and also on the Kubernetes nodes, which report back things like CPU and memory, right? So you kind of get built-in metrics with Kubernetes, which is fantastic. All right, so actually in this case, you can see that we just went ahead and deployed our latest version of code. This just got updated about a minute ago. So we pop back open here. You can see we have our new updated version already deployed, which is great. And you can see how easy it is to go ahead and deploy into, for example, Kubernetes and automating your pipeline here. And it gets also even easier, right? So I mentioned before how Kubernetes can easily scale your application. So if we pop in here, for example, and go to CI/CD settings, we can actually tell our script to increase the number of replicas that we want, the number of pods or nodes. So we can say, you know what, we want, say, 5 nodes instead of just 1. We add that into our variable here. We go back to our environment. We redeploy. And in a couple of seconds here, we'll go from 1 pod to 5 as we rerun that job. And that gives you an example of, again, how easy it is to scale. And you can do it, of course, through deployment job like you see here. You also can set up auto scaling routines on Kubernetes itself to handle this automatically for you. So there's a bunch of options there for handling sort of how elastic you want. But in this case, you can see, for example, that we have now a 5 total. 1, of course, is currently running, and we're now spinning up the rest of the 4 here automatically, as you can see. So pretty awesome there around how easy, again, it is to work with Kubernetes and scale up, scale down, update as well. So we've been using here sort of that kind of auto DevOps-y pipeline, but you can actually take a look at that pipeline in our template library, right? So we have a great library of a bunch of samples for a variety of languages. But in this case, let's take a look at our auto DevOps template. And you can see exactly all of the logic that we use to build this. So you can see we have our build stage, our test stage, review, and some additional stages you might not have seen before, like staging and canary. These are actually optional, right? So you can actually go in here and take a look at perhaps a staging environment if you want to have kind of that initial test before simply deploying into production, as well as canary, which is a really cool feature of a lot of this cloud native architecture and Kubernetes. In this case, we can go ahead and deploy a single node or a single set of nodes out of the entire fleet, deploy it with sort of the new version or N+1, make sure it's running as you'd expect and running healthily and not generating errors. And if it is, you can continue to roll out the rest of the deploy across the rest of your fleet safely and again with reduced risk, right? So as you kind of consider your iteration cycle, some advanced deployment strategies like canaries here can really help to reduce risk, maintain velocity, and this is just one example of how easy it is with, again, leveraging cloud native applications like Kubernetes here. So that's a really quick example here of sort of taking an application from development to production and how easy it can be. We can actually pop into a job here and take a look at exactly that deployment stage, what that looks like. So you can see in this case, we're going to go ahead and create a couple of things. We're going to leverage Helm in this case to deploy. We're going to go ahead and actually generate the chart. We're going to then go through and actually install Tiller, which is the sort of server-side Helm component that you use for deploying software into Kubernetes. And then we're going to go ahead and actually create some of the sort of Kubernetes constructs. And so if you're familiar with secrets, they're sort of like configuration settings in Kubernetes land. And we'll go through and create deployments and services and also the storage or a PVC. And so you can see how that works here as far as the output. And then again, the actual job is available in our template with the full details. So I think we'll pause there for any kind of questions or people might have on this particular sort of example or demonstration here.
Hey, thanks for that, Josh. I don't know if everyone's feeling very shy, but we've had no questions so far, which I think means that you're just nailing it so much that there's no extra information required. But I'd say just keep going, man, and maybe they'll pop up at the end.
Okay, so what we can do, we can go ahead and actually do a quick deploy of canaries. So let's go through and take a look at our pipeline here. See what that would look like. So we can go through, find our canary job here, uncomment that, go to our production job and make this manual. And this way you can have a manual sort of trigger to go through and complete that deployment. We'll commit this back into master. And you can see we'll have a new pipeline that's now running, and we'll have a new job that's available, which is now our canary job. So it's like a couple seconds to go through and rebuild our container and complete our tests. But then you can see, for example, in this case, the illustration of what a canary looks like here. It's not going to have a different sort of UI since we're leveraging the same sort of code base, but you'll see the stage pop up here as well. So if you take a look at the build stage, that actually is already completed. You take a look at code quality here as well. You can see we're pulling the container down to go ahead and run the code quality analysis. Once we're done with that, we'll persist the JSON output and then use that for comparison to the sort of destination branch. In this case, we're running a master. So this is sort of the official kind of thing you're comparing it against. And then once we're done there, we'll have our canary job here in just a couple seconds. So we'll deploy the canary. You can see it's going to go ahead and deploy to production. So take just a couple seconds here. We're spinning up our runner. Our runner actually, by the way, which is what processes the CI jobs, can elastically scale itself to handle your queue depth. And so it'll only consume as much resources as required to process your CI jobs. And so in this case, you can see it just completed the deployment. We went through and ensured Tiller was there. We went through and deployed our canary. So now if we pop back over to our environment, you will see we now have one of our canary nodes running, which is denoted as that yellow, right? So we have one canary, 5 production, and we can now go ahead and test. And again, this is the same code base in this case, but normally you'd have, say, for example, a different revision running in the canary. And so in this case, 1 out of every 6 requests would get fed automatically to the canary. And when you can have, again, that limited test bed, for example, and then once you're happy with it, you can simply go ahead and complete the deploy to production which should spin down the canary and take that container and deploy it out across the rest of the deployment here. So some cool examples there of how you can, again, leverage the programmability and the cloud native aspect of Kubernetes and containers to really get some increased velocity and some deployments that can help you reduce the risk of moving quickly here.
Thanks for that, Josh. And it turns out that actually, I want to apologize for those people that were asking questions. Due to some quirk in the UI here, I couldn't see them, but some of the other panelists could. So there had been a couple of questions coming through. And the first one is from Mark Bell, who asks, in terms of cloud native adoption within the enterprise space, how far along is the market? 5%, 25%, more?
That is a great question. I wish I had hard numbers on this. All I can go by here is sort of, our segment of folks that, our customers or whatnot, or what we're seeing, sort of anecdotally. My gut is that it's, somewhere between the 5 and 25% part. I know that a lot of enterprises are toying with cloud native, or more specifically, I'd say toying with Kubernetes. Like everybody's doing something with Docker. And usually, you'll start with Docker in a test environment, like maybe you're using it literally as part of your CI or something like that, or you'll make a bunch of Docker images for a whole bunch of stages, except deployment into production. And then when people get into production, Kubernetes is clearly the top thing that's on their mind. But most enterprises are still playing with it. They're still trying to figure it out. Clearly some have, but I'd have to guess that it's in the low, maybe around 10% or something like that, or maybe even less. But I'd be shocked if it was more than 25% for sure.
Thanks, Mark. There's another question here, which actually Camille had to post through. It's worth pointing out that if you are now putting questions into the Q&A, don't do that because I can't see them. Drop them into the chat instead. I'm sorry that I don't know your name, but whoever it was that asked the following question, thank you for that. Question is, with security being a big concern within the enterprise and underlying infrastructure is typically behind corporate proxies and firewalls, in what ways is GitLab or the CNCF able to assist or drive the industry to make it easier to deploy cloud native technologies within these environments? Great question.
So yes, this is in fact very great question, because like at GitLab we always put a lot of emphasis on the security and on enterprise solution. So I would say that GitLab is basically this kind of solution that tries to figure out the best practices, the best tools that could be used in enterprise, and tries to integrate them into the product that actually makes it very easy to run that in your infrastructure that is behind the corporate firewall. One of these examples is exactly container registry, something that is, if you try to do it manually, it's kind of complicated to set up, but with the way how the GitLab basically builds that and interacts with that, it just becomes the breeze to use that. Then another example is the integration with Prometheus. It's yet another good integration that GitLab is proposing. So as long as we are basically in the process of building better workflows that are using the cloud native proposed tools that basically in the end will make it really easy to use that in enterprise with these very high requirements for the security and connectivity to the outside world.
Thanks, Camille. And if that didn't answer your question, please let us know. We've got another 9 minutes. Josh, were you at the end of the slides, or did I cut you off and there was some more to come?
No, yeah, so we got a couple more slides we can just maybe go through while we're waiting for some more questions here. But basically, we're pretty much essentially done. Got it. This one's here, just the complete DevOps. Basically, this is sort of what we're going through here, and also what we're trying to help enable folks with GitLab. To be able to have a sort of complete process from planning to creation to package, release, configure, deploy, monitor, and then kind of take those learnings and funnel it back into the system. So this is kind of like our goal and our vision. We announced it here actually for our 2018 plan. There's a link at the bottom if you're curious. Check it out for more detail where we're going. What we really want to try and make sure we do is enable more folks to embrace cloud applications, and we can make it as easy as possible, as sort of what Camille mentioned before, some of the work on the container registry, that we can sort of make it turnkey, where otherwise it might be a little more work to get up and stand up in your own environment. So That's what we're trying to do here, is try and make it as easy as possible to kind of get started on this journey for yourself. And that's it.
Great. Thank you so much, Josh. We have one more question coming through. Apparently, what version of GitLab is being used in the demo? Should be an easy one.
This is 10.0.3, so it is the latest and greatest version. So yeah.
All right. So we're coming up to the top of the hour. Camille, have I missed any other questions anywhere? Since it seems that you're seeing them all and I can't see any of them.
No, I think that these were our questions that we received.
Great.
Thank you, Mark.
If you have watched this and either weren't brave enough or couldn't think of the question at the time, we can provide contact details for the speakers later, and we'll do. I'll provide the link at the end so you can see where to go for all that kind of stuff. All that's left for me to do is thank Josh, Mark, and Camille for a fantastic webinar, and to thank you all for coming along and supporting and coming up with the questions today. I think that's all we've got time for, unless there are any final points any of the panelists would like to make.
Yep. Thanks, everyone, for taking the time to listen in. Hopefully it was helpful.
Excellent.
Yeah, thanks, Mike, for hosting.
Oh, that's my pleasure. Thanks again. Oh, actually, one thing I'll do is I'll put this link here in the chat. If this is your first CNCF webinar, you can go there and see all the ones that we have coming up. We were initially running them monthly, but now we're going to bi-weekly. And there's lots and lots of good content like this coming through, so it's worth keeping an eye on there and signing up in advance. That's it for now. Thank you, everyone, and goodbye.